Okay, so we're going to do the last example here to finish off our lesson on related rates. So the directions here say that a trough is 10 feet long and its ends have the shape of isosceles triangles that are 3 feet across the top and have a height of 1 foot. It says if the trough is being filled with water at a rate of 12 cubic feet per minute, how fast is the water level rising when the water is 6 inches deep? Okay, so when it says we have a trough whose bases are isosceles triangles, that's like saying that we're looking at a triangular prism. Okay, so let's go ahead and list the information that we are given in the problem. So we're told that the trough is 10 feet long. Okay, so that's going to make L equal 10. And then we're told that the bases are isosceles triangles that are 3 feet across the top. Okay, so that distance there is going to be 3 and has a height of 1 foot. Okay, so that's going to be 1 for the height. And then it says if the trough is being filled with water at a rate of 12 cubic feet per minute. Okay, so it's a rate number 1, and the unit of measure is going to tell us what rate we're looking at. So cubic feet per minute is a change in volume with respect to time. So that tells us dV dt is equal to 12, and if water is being filled, then the volume is getting bigger, thereby making that rate positive. Then how fast is the water level rising? So that is asking us to solve for dH dt in the question when the water is 6 inches deep. Okay, so that's a little tricky in that, like, all of your other linear distances are measured in terms of feet. So the fact that that is in terms of inches, we want to write that measurement in terms of feet. So 6 inches is half a foot. So that tells us that h is going to be equal to 1/2. Okay, so let's go ahead and write our static equation, and then we're going to take the derivative of that, and we're going to see kind of like what problems we run into in doing so. So when we find the volume of a prism, volume is going to be the area of the base, which in this case is a triangle. So area of a triangle is going to be 1/2 the base times the height, and then we have to multiply that by the length. So it's 1/2 BHL, okay? And what we're going to want to do here is to take the derivative with respect to t of that equation, okay? So when we do so, the derivative of the left-hand side is dV dt. We can pull 1/2 out in front. Now this is the first time we've seen this, but when we look at the right-hand side, b times h times L, that's actually the product of 3 functions. So if we're going to do product rule with 3 functions, it's going to be the derivative of the first, so dB dt, times the second and the third, plus the derivative of the second, which is dH dt, times the first times the last, plus the derivative of the third function, which is dL dt, times the first times the second. Okay? So if we are solving for dH dt, right, that's what we're solving for in this question, we need to know what everything else is in the problem. Okay? So we need to know what dV dt is. Great, we have that. We need to know what dB dt is. We don't know what dB dt is. So that's a problem for us that we're going to have to work around. Okay, we don't know what dB dt is going to be. We know what h is. We know what L is. We could potentially figure out what b is. And the way that we would do that is we can look to the dimensions of our triangular base. And we know that for the dimensions of that triangular base, The base length of that triangle is 3, and the height is 1, so that means that 3 heights equal a base. Okay, so like we could determine what B is if we needed to. And we would also need to know what dl dt is. Well, we're not explicitly told what dl dt is, but we can infer what dl dt is, because if we're filling that trough with water, like the length is not going to change. Like that length is going to be the same as that trough fills up. So that means that dl dt is going to be equal to 0. So the one problematic thing we have here is we do not know what dB dt is. So just like we did with the cone problems, we can work our way around that issue by getting our formula written in terms of H and L only, okay? And if we go to this statement that we made right here, we can substitute for B. We can replace B with 3H, which is going to allow us to write that volume formula in terms of H and L. So let's go ahead and do that, and that'll work us around the problem of not knowing what dB dt is. Okay, so our volume here is going to be 1/2 times B, which we said was 3H, times H times L. So if I simplify that, we get volume here. 3 times 1/2 is 3/2. H times H is H squared times L. And then we're going to go ahead and take the derivative of this with respect to t. And when we do that, we will have everything that we need in order to solve for dH dt. Okay, so the derivative of the left-hand side is dV dt. We can pull 3/2 out front and then use product rule to take the derivative of H squared times L. So that's going to be the derivative of the first, 2H dH dt, times the second, L, plus the first, H squared, times the derivative of the second, dl dt. Okay, so all we have to do is just plug stuff into our equation here. So dV dt is 12, and that's equal to 3/2 times 2 times H, which is 1/2, times dH dt, which is what we're solving for, times L, which is 10, plus H squared, which is 1/2 squared, times dl dt is 0. Okay, so the factors of 2 and 1/2 cancel. When I multiply 3, okay, also this right here is going to be equal to 0, so I don't have to worry about that. So when I multiply 3/2 times 10, on the left-hand side we get 12. On the right-hand side, 3/2 times 10 is 15 dH dt. So we get dH dt is equal to 12 over 15, which makes dH dt, both 12 and 15 are divisible by 3, so that becomes 4 over 5. Height is measured in terms of feet. Time is measured in terms of minutes. So the change in height with respect to time is 4 feet every 5 minutes. Okay, so again, as you guys see, what I did with this example and what I did with the cone examples is a lot of times I took the volume equation, took the derivative of that, and that allowed me to see what information can I not determine? And then how do I work around that problem of not knowing a bit of information? That's going to allow me to write my formula in terms of one variable or in terms of two variables that gets me around the problem of not knowing a specific variable in that formula or a specific rate in that formula. Okay, so that's it with related rates, guys. You should be able to complete the homework assignment that's due on Sunday. So hope you guys have a great Thanksgiving break. Again, be on the lookout. I'm going to post the other 2 videos that you need to work on over Thanksgiving break on Chapter 5. Probably do that likely tonight or tomorrow sometime. Okay, so take care, everybody. We'll see you again soon. Bye.